and get started. So my name's Angela. I'm a recitation leader for 995.
And I'm Allie. I'm a tutor at the MLAC.
So if you guys have any questions, you can definitely ask us. We won't ask your guys' name just because of policy for school stuff. But please let us know if you have any questions. And yeah, we'll go ahead and get started. Do you want to start us off and then?
Sure.
Okay.
Yeah. Okay. So we're reviewing for CBE 2, goes over polynomials and everything. So we're going to go over, again, polynomials, multiplying and dividing, factors, and the greatest common, greatest common multiple? Yeah. Factor by grouping, factoring trinomials, and special factoring formulas. So, okay, so we're just going to start polynomials in general. Want me to just take this next section?
Go for it.
Okay. All right, so polynomials are a finite or ending sum of terms where each consists of a variable, usually x raised to some power, with a constant coefficient. So we have an example up there, 4x cubed plus 2x squared plus x plus 1. So terms are the things that are added and subtracted. The coefficient and the variable together make up one term. So the coefficient is that number in front of the variable, and the degree is the highest power. So with this example, we would say it's degree 3, because the highest power is x cubed. Okay, so we have our first problem here to review. We're going to be subtracting the polynomials and simplifying the expression. So it's like it says in our little note here, remember that we were subtracting the whole polynomial on the right. So that negative we have to, quote unquote, distribute throughout that whole second expression. So we'll take our first expression. Okay. 5m to the 5th plus 4m cubed minus m.
What do you guys think we're going to do for the next terms? What are those going to look like? Oh, come on in. Take a sit anywhere. Yeah.
We have to make all the positives negative and the negatives positive.
Perfect.
Beautiful, wonderful. Okay, so that's going to switch our 2m squared to negative 2m squared, our plus 6m to minus 6m, and that negative 7 to plus 7. Okay, any ideas on next step? Which ones? How we're going to combine this and simplify?
So you do negative m minus 6m to negative 7m. I think that's the only one you can combine, right?
Combine like terms.
Yep, we're looking for those like terms. So yeah. So we have the negative m and the negative 6m. And yeah, it looks like those are our only two like terms. So that 5m to the 5th will stay the same, plus 4m cubed. And I'm going to go ahead and order these in descending order of power. So we're going to do our negative minus 2m squared. And then that minus m and minus 6m, we can combine to that minus 7m plus 7. Okay, we feel good about that process, that step? Okay, we're just jumping in with you guys, but we're just talking about subtracting polynomials. Key thing we noticed is that negative, since we're subtracting that entire expression on the right, we need to make sure that that negative or that minus gets distributed all the way through. Okay? All right, and we can check ourselves. 5m to the 5th plus 4m cubed minus 2m squared minus 7m plus 7. Awesome.
Sweet.
Okay, problem number 2. Determine the value of the polynomial 3x squared plus 6x minus 10 when x equals 2. Okay, who feels like they have a good idea of what process we're going to do here, what we're trying to do? Okay, does anybody else? Because I know you've answered a couple of our questions. Yeah?
Substitute the 2 into the equation given.
Exactly, yeah. Everywhere we have an x in our expression, we'll put 2 instead. Okay. So 3, and then that x becomes 2 squared plus 6 times 2 minus 10. Okay, and then we can simplify. So 2 squared will give us 4 times 4. Do our multiplication then. 3 times 4 will give us 12. Plus 6 times 2 is also 12. minus 10. Final answer, anybody? 14? Okay.
Speedy quick.
Check ourselves on that. 14. Perfect. Okay, any questions on those last two problems that we just went over? Okay,
Feeling pretty solid.
good start, guys.
Okay, awesome. Okay, we're gonna go over multiplying polynomials. So, multiplication is commutative, which basically means that the result is going to be the same no matter what order you multiply them in. So, an example would be 3 times 5. You could also do 5 times 3. Both of them are going to give you 15. Same with these two factors. So you have 3x plus 7 times x minus 1. You could just switch the order of the factors. You could have x minus 1 times 3x plus 7. You're going to get the same answer. So when multiplying polynomials, we can use the distributive property where we take what's on the outside and we can distribute it in. So a times b plus a times c. If we had something crazy long like this one with all letters, love that for us. So we have E that you would multiply by both the G plus the H, and then you'd have F that you would multiply by both the G plus the H. So then you'd be left with this final term. Okay, any questions about this before we go into some problems? Perfect. Okay, awesome. Okay, so we get some practice here. So I'm curious, what is your guys' first step? Where would you guys start? Someone besides these two. Someone over here on the back table. Where would you start?
I'd multiply 4y to all the other numbers in the other parentheses.
So in this one, perfect. So you're saying multiply this one by 3y squared, and then by 2y, and then by 1. Perfect. Okay, so yeah, I love it. So 4y squared times 3y squared gives us what?
12y cubed.
Close.
Oh wait. I don't know. It's the 4th power.
Perfect, yes, exactly. So yeah, when we're multiplying by exponents, we're just going to be adding them. So 2 plus 2 is going to give us 4. So yeah, perfect. Okay, and then this next one's going to give us a cubed power. What do we get when we multiply 4y squared by 2y?
8.
8y.
Cubed.
Perfect. Okay, awesome. And then what about our last term? 4y squared times negative 1.
Negative 4y squared.
Perfect. Okay, awesome. So 4y squared's done. What do we need to do next, or are we done?
Now do the 10.
Now we have to do the 10. Perfect. So we're going to take this one. I'm going to do this under so you guys can see we have to do all of our steps. Perfect. So then 10 times 3y squared gives us what?
30y squared.
Perfect. 10 times 2y gives us what?
20y squared.
20. Sorry, I did not do 20y. Perfect. And then 10 times negative 1.
Negative 10.
Perfect. Alrighty. Okay, do we see any like terms in here?
Negative 4y squared and 30y squared.
Yeah, I agree with that. Perfect. So, since those are our only ones that look like there are like terms, I'll just write the first couple terms the same. So we have 12y to the 4th plus 8y cubed. What do we get when we add those together? 26, perfect. 26 y squared. And then we can just write our other two terms. So yeah. Then we can sanity check. Perfect. Okay. Any questions on this? Awesome. Okay. Let's do one more. So this one is more like a story problem. So they give us the area of a rectangle, they give us the width, and then they give us the length. What, first of all, is, okay, well, it tells us. But in the test, if they were like, what is the area of a rectangle, what would you guys say? Width times length. Perfect. Awesome. It does give us it up here, but in the test, I don't know if they would necessarily give that to you. They might want you to know that. So in this case, we have our width, which is 4x minus 6, and then they give us our length, and they're wanting us to multiply it, so we have 2x plus 9. Perfect. Okay, so where do you guys want to start?
We should foil that thing.
Foil it?
Yep.
Okay. We didn't ever say FOIL before. What does FOIL stand for?
First, then outside, inside, last.
Perfect. So first terms, and then the very last outside terms, sorry, bless my heart. Outside terms, we have our inside terms, and then we have our last terms. So it kind of just helps us give us a sanity check to see if we're multiplying everything we need to first. Perfect. So first ones, what is 4x times 2x?
8x squared.
Perfect. Okay, and then we have our outside terms, 4x times 9. 36x? Perfect. Okay, and then our inside terms, -6 and 2x. That's
-12x.
-12x. Perfect. And then -6 times 9?
-54.
-54, yeah. Took me, I was like, wait a second. Okay, awesome. Perfect. Is there anything we can combine in here? Any like terms that you guys are noticing?
36 and 4.
36. Perfect. And this -12. Awesome. Okay, so then 36 minus 12. 24. Yeah. You get 8x squared plus 24x minus 54. Sanity check. Nice. Okay, awesome. Oh. I have a negative. It should be a -54, right?
Oh, yeah, that should be negative.
That's a negative. That is a negative. We'll just write a negative down here. That's a good thing to do. Okay, perfect. It would be negative. So, okay, awesome. Any questions on multiplying polynomials? Perfect. Okay, awesome.
Alrighty. Okay, that takes us to our next dividing polynomial.
This is the fun one.
Yeah. Okay, this is one that I feel like as a tutor, sometimes I see students come in with and they're like less sure. Can I just get like a thumbs up, thumbs down on how each of you feel about it right now? Feeling pretty good? Okay, that's good. Just want to know how in depth we need to be with our questions and our explanations. Okay, so dividing polynomials by a monomial. Oh, monomial. I always struggle saying that word, which is just one term. We are going to divide into each term in the numerator, which is our distributive property, and we can simplify each term by looking for common factors. So pretty kind of like what we were doing just with multiplying, wanting to make sure that each term gets, distributed correctly to every other term, and then that we simplify. When it comes to dividing polynomials, we cannot just divide individual terms with each other. We are dividing by the entire quantity. And instead, we use long division, which we'll go over that setup. And then similar to long division with numbers, remember to include your remainder when finished. So if we have something left over, we need to account for it. We can't just toss it aside. Okay, so our problem here, divide and simplify the following expression. 8x to the 5th plus 6x squared plus 5 over 4x to the 4th. So our last slide kind of gave us a hint of similar to long division with numbers. Any ideas on how we want to set this up to do it? Or do we feel good just using the fraction form?
I like to put everything over, 8x to the 5th over 4x to the 4th plus 6x squared.
Gotcha. Okay, yeah. Okay, so you're talking here we've got our 8x to the 5th over 4x to the 4th plus 6x squared over 4x to the 4th plus 5 over 4x to the 4th. Wonderful. Okay, so what's your next step with that?
Starting with the first one, you can turn it into 2x over 1, right?
How do you know that?
Because, I don't know how to explain it.
Quotient rule with the exponent is 5 minus 4. So it's
Beautiful.
just x, and then 8 divided by 4 is 2.
Perfect. Yep. So we're simplifying our coefficients and we're simplifying our variables and their exponent powers. So yes, perfect. X over 4 is going to simplify to 2. And then quotient rule, x to the 5th divided by x to the 4th is going to leave us with just x to the 1st, but we can just write just x. Okay, so can we apply that same kind of thing to our second term?
Yes.
Similar method, right? We can look at coefficients and then our exponents and our variables. Okay, so how can we simplify this term? It won't simplify as well as our first term, as small, but we can simplify it and reduce it a little bit.
Divide 6 and 4 by 2.
Yep, wonderful. What does that leave us with?
3 over 2.
Mm-hmm. Okay, and then what about our x's?
The same thing we did. So, subtract.
Yep. So it's gonna, I can see we got 2 minus 4, which gives us -2. What does that -2 exponent mean?
Bring it to the bottom.
Yep, it's in our denominator. Perfect. So that means in our denominator, we're gonna have our x squared. Okay. Okay, and then anything with that last term.
Just stay the same.
Yep, it's just gonna stay the same. Nothing that we can divide out of 5 and 4, and the numerator doesn't have any x. So we'll just stay the same. Okay, we can check ourselves there. 2x plus 3 over 2x squared plus 5 over 4x to the 4th.
Let's go.
We feeling good about the problem?
Yep.
Okay, nice job. Okay, our next one, now we have, this one's not a monomial, so we have our polynomial that we're dividing by. Who feels good about setting this one up? You want to tell me how to do it?
Set it up like long division, so
Mm-hmm.
x plus 1, and then like that weird thing.
Yep, our
And
little.
leave the rest of that.
Mm-hmm.
And then the top one in there.
And then everything in the numerator goes inside there.
Is there anything you guys want to add?
Oh, an x. So like plus 0,
Oh,
x,
the
and then
same.
minus 6. Perfect.
Yeah, we want to make sure that all of our exponent values are represented. So we have our x cubed, we have an x squared, but we don't have an x to the first power. So we're going to do 0x minus 6. Okay, wonderful. All right, so now we're ready to start our actual division. What's our first step with that?
Match is like 2x cubed. Like x. I don't know how to explain this. So 2x squared times x equals 2x.
Yeah, we want to look. Yep, we want to look how many times can our leading term in our denominator, or the polynomial that we're dividing by, go into the first term of our numerator. So yeah, exactly that, 2x squared. Because if we multiply 2x squared by x, it would give us our 2x cubed. So nice job. Let me erase those really quick. Okay. All right. Okay, so we have that. What's next?
Multiply the 2x squared times x to get 2x cubed, and then by the 1 to line it up with the 4x squared.
Yep. So we're going to actually divide that term out. And so, yep, exactly. We're going to multiply this term that we just wrote, the 2x squared, by each term in our dividing polynomial. So 2x squared times x gives us that 2x cubed. And then 2x squared times 1 gives us 2x squared. And then we're going to subtract that whole term that we just got, that whole expression from what's inside of our division here. So that's going to make both of those negatives. Okay.
Can you re-explain the first column? Because you have 2x to the 2x squared, and then what did you do to get negative 2x?
Yeah.
Cube.
Okay, I'm just going to go ahead and erase this and we can go back through it together. Okay, well, very first thing that we're going to do is we're going to take that 2x squared, because we figured that x can go into 2x cubed, 2x squared times.
Okay.
Okay, and we know that because x times 2x squared gives us 2x cubed. Okay,
Okay.
so that's where 2x squared comes from. Okay, then we're going to take that 2x squared, we're going to multiply it by the whole expression we're dividing by. Plus 1, thank you. So x plus 1. Okay, then we're going to do like what we did with multiplying, make sure that we multiply each term. So that's where we get our 2x cubed plus 2x squared.
Okay.
Okay? And then we're going to take this new expression that we got from multiplying those two together and subtract it from our numerator, or that number that's inside of our division symbol. So this 2x cubed plus 2x squared, we're going to subtract that from 2x cubed plus 4x squared minus 6. Okay, so that's what switches our signs. And we're going to have that minus 2x cubed minus 2x squared. Does that make more sense?
I think so, yeah.
Okay. What are we going to be left over with after we subtract that?
2x squared.
Perfect, 2x squared. Okay, and then here, similar to how we have like this 0x here, we're kind of imagining we're also subtracting zeros off of there because there's nothing there. So we can just bring down all of our other terms, right? Okay, so that plus 0x, that minus 6, they're going to come down also. Okay. Do you want to try with our next step here? Talking through what to do? If you're not sure about it, we can talk about it. I just want to make sure you feel confident when you go into the CBE.
Do you multiply the x plus 1 again, or?
Yeah, so very first what we're going to want to see is we're going to want to say, okay, how many times can x go into 2x squared? Because now this is our leading term, is that 2x squared.
Okay.
Okay. Or in other words, what could we multiply x by to give us 2x squared?
Okay.
Okay.
So 2x.
2x, perfect, yeah. And it's positive, right? So I'm going to do, since it's positive, we're going to do plus 2x up here.
Okay.
All right.
And now your next step would be multiplying by that x plus 1.
Okay.
Yep, now we're ready to multiply that whole expression, the x plus 1.
Then do you get 2x squared again?
So 2x squared, and then we want to do our 2x times 1 also.
So then you just get 2x.
2x, perfect. Okay, so this is like that.
Okay.
And then since we're going to subtract that whole term, or that whole expression, we're going to come through and flip our signs on everything. So now we have minus 2x squared minus 2x. Subtract that whole thing there. Okay, so what are we left over after that? After we do that subtraction.
Negative 2x minus 6.
Negative 2x minus 6. Beautiful. Okay. Who knows what's next?
And then you do the same thing with the multiplication.
Mm-hmm.
So it'd be minus 2.
Yeah.
Times x. And then minus 2 plus 1, which is
Mm-hmm.
negative 2x plus 2. Wait, minus 2.
Minus 2. And then again, since we're subtracting that whole expression, I'm going to go through and flip those. Yep. Okay, awesome. Okay. So that becomes plus and that becomes plus. Okay, I kind of ran out of room here. So we're going to just come over here. Okay, so what are we going to be left over with after that?
-4.
-4, awesome. Okay, and can we do any more division here? No, we know because x doesn't go into 4. It's not going to divide out. Okay, so we have done all the division that we can. What do we do with our answer now?
You take what's on the top of the division sign and then add it to the remainder, so negative 4 divided by x.
Beautiful, yep. So we're going to take this quotient, what's up here, our 2x squared plus 2x minus 2. And then our remainder, we don't want to forget about that, which has to still go over our divisor, x plus 1. Yep. And then this would be our final answer. Okay, let's check ourselves. 2x squared plus 2x minus 2 minus 4 over x plus 1. Beautiful, guys. How are we feeling about that whole process? Does it make a little bit more sense now? Is there any parts that we aren't sure about or we worry about doing on our own?
I don't know, like it's confusing because I don't know what step, like, to bring it, it's like you bring it to the top, but then you also like multiply it by the side again, like you do that twice, like you divide it by the side. Like,
Yeah.
it's kind of like this to me, it seems like. I don't know how to explain it,
Me
but
too.
It's kind of like a circle. You have to like go in like a circular motion.
Mm-hmm.
I know when Janet teaches this, she likes moving things over. So you have the 2x squared above the 4x squared. And then since there's nothing in front of the x cubed, you have to be able to get rid of everything in the x cubed spot. So then you can move your process over and then solve down by where your x squared was.
okay.
So when you're multiplying by your 2x squared, that's how many times it goes into x, like your 2x cubed, but you still have your 2x cubed that you started with, so you have to get rid of that to know, okay, now I'm in my x squared spot. I got rid of x cubed, now I'm going to my x squared, then I'll go to my x, and then I'll go to whatever the last part, like spot is. And so to be able to get to your x squared spot, you have to get rid of everything that's inside of your x cubed spot. So that's why we have to multiply again by that 2x squared, is because then we're seeing, okay, well 2x squared times x, we already knew that it gave us 2x cubed because that's what we divided by when we got our 2x squared. And then we also just have to add the 2x squared by the 1, and that's going to be able to shift our whole process over to then solve for our x squared.
Does that help it make a little bit more sense?
Yeah.
One way I like to think about it is if we think about multiplication as like repeated addition, division is going to be repeated subtraction. And so we want to make sure that we're subtracting off everything that we can. So we do that first like division to like make sure we get the number, multiply it, and then we have to multiply by the whole expression to subtract everything we can. And then we go to our next file and say, okay, now what can I subtract off of this? What's left over? We keep doing that process. Yeah, it's like really circular. Just got to keep going through it to make sure you subtract off everything you can, or that you divide out everything that you can, until we're left with that term that you can't divide. Okay.
And after this, if you guys want some more practice, like we can do a couple more of these as well. So, because I think these are probably the hardest.
Yeah, like I said, division
Once
is
to
one
grasp.
that like it's kind of hard to grasp, like wrap your mind around, like why you're doing every step that you're doing. So, okay, do we feel ready to go on for now? Okay, awesome.
Perfect. Okay, so now we're going to go into factoring. So factors are numbers that multiply together to make a number. We can think about doing multiplication. So kind of like division, factors are where you have your two things in parentheses, and then you're going to divide out evenly, and then write them as products of those divisors. Wow, that made no sense whatsoever. Okay, so the greatest common factor is the largest factor of a group of numbers that they all have in common. And we'll kind of go over this a little bit more. But yeah, let's go into this. So we started doing this a little bit in class. Factoring trinomials where you have three different terms. They're all written in descending order, so you usually have like something with an x squared and then an x and then something that doesn't have an x with it. And this is where we talked about foiling before. This is where we want to unfoil. So when the leading coefficient is 1, we find the factors for just the last term that add to make the middle term. When we don't have 1 as the leading coefficient, we multiply the leading coefficient number by the last number, and then we find the factors for that number that add to the middle number. So Any questions so far? Kind of like lots of vocabulary. We'll get into some examples, but yeah. So in this case, first of all, what is my leading coefficient for this one? What is my leading term? 1. Perfect. It's not even written there, but I could write a 1 and it wouldn't change anything. So in this case, what are we wanting to use to factor to get to our middle term? What are we wanting to use?
The 6.
The 6. Perfect. Okay. So I'm going to write 6 here. So what are my factors of 6?
1 and 6 and 2 and 3.
Perfect. 1 and 6 and 2 and 3. Okay, perfect. So we're wanting one of these, I guess, factors to be able to add together to get -5. When we have a positive, so this is over here, this is a positive 6, right? 1 times positive 6 gives us a positive 6. So we either need 2 positive numbers to multiply together or 2 negative numbers to multiply together to be able to give us a positive 6. So in this case, we wrote down all of our positive values. But what is another way we could write down all of our factors if I wanted to still get to a positive 6 but have negative values for my factors? If that made any sense whatsoever. I can give you guys like the first one. So this would be like -1 times -6 would still give us a positive 6, but those are still factors of positive 6. So what would be my other 2 terms that I would have for my factors?
We need a -2 and a -3.
Perfect. -2, -3. Okay. So here are all of my factors. Fabulous. So out of all of these, do any of these terms add up together to get -5? The 2 and the 3. Positive 2 or the 3, or the -2 and the 3? The -2 and the 3. Perfect. So we're going to rewrite this, and we're going to write 1x squared. You don't have to write the 1. I'm just writing it, so it's like a sanity check for me. And then we have negative. Do you guys want -2x or -3x first? It doesn't necessarily matter. -2? Perfect. So we'll do -2x, and then we'll have -3x, and we'll have +6. Okay, any questions about how we got there before we move on? Okay, something I want to highlight that I have definitely messed up on. When you are taking these terms and you're putting it in the middle, don't change the first and the last term. Keep those the exact same. These are just replacing what you have in the middle. So everything in the middle will change. The 2 outside terms are going to stay the same. Okay? Perfect. Okay, so then what can we do from here?
Factor out, or
I'm seeing this. Yes.
Yeah.
Factor by grouping. Perfect. So we're going to put these first 2 terms together and these last 2 terms together. So yeah, perfect. So then what can we factor out of this first set of terms? This x squared minus 2x.
X.
Perfect. So when we take an x out of both of these terms, what are we left with?
X minus 2.
X minus 2. Perfect. Any questions about how I got there? Okay, perfect. What about this second set of terms? -3x plus 6.
3.
Perfect. Let's take a 3 out. And then we are left with -x plus 2. Okay. So this is where you always want your 2 terms in parentheses to match each other. So do these 2 match each other as of now?
No.
They don't. So if they don't, what you want to do is you want to see if there's something that you can take out of either one of these to make it so that they do match. So in this case, I like positive x's. So I might look at this second term. Is there anything else I can take out of this second term so that my x will be positive?
Negative.
You can take a negative out. Perfect. I'm going to take this negative out here. I'm going to rewrite this. So we have x times x minus 2. That doesn't change. But I'm going to make this a -3. And then what am I left with when I take a negative out of both of these terms? Perfect. X
Minus 2.
Perfect. X minus 2. Perfect. Okay, now do my middle terms match? Yeah, they do. So once these two match, I can just take these middle terms and I can write x minus 2 because both of these are multiplied by x minus 2. What are my other two terms that I have?
X and -3.
Perfect. X and -3. So you can write another term with these two and you can have x minus 3 as your other factor. Kind of bougie. We love how that works. So, okay, any questions on this? Okay, if you understand this process, when we get to terms that have not a 1 in front of the leading coefficient, you can still do it because it's the same process. Okay, so let's sanity check. Oh, so proud of us guys, we did it. Let's go. Okay, let's look at this one. Okay. Do I have a 1 in front of my leading coefficient?
No.
As my leading coefficient. No, we don't. What do we have?
6.
We have a 6, okay. First of all, is there anything I can take out of any of these so that I could maybe get rid of the 6? I'm not seeing anything. Okay. Well, that's a sad day for us, but we can still do this. So, what do we now have to do to be able to find what we can get rid of as far as our middle terms go or replace them? What do we have to do with our leading coefficient and our last coefficient?
Multiply them.
We do have to multiply them. So this 6 and this -10 multiplied together, what is 6 times -10?
-60.
-60. Perfect. Okay. Oh boy. Okay. List off some factors. What factors give us -60?
1 and 60, 2 and 30, 3 and 20, 4 and 50, yeah.
10 and 6.
10 and 6. Okay. Perfect. I think that's it. Look at us go. Okay. So, in this case, we have a -60, correct? So one of our factors has to be negative when multiplied to the other one so that we get a -60. So, are there any terms here that might give us 11 if one of them was negative?
4 and 15.
4 and 15, I definitely agree. Which one would have to be negative for that to work?
The 4.
The 4. Perfect. Awesome. So let's rewrite this. We have 6x squared. Do you guys want the 4 or the 15 first?
The 4.
The 4. Perfect. So we have a -4x, and then we have a plus 15x, and we have a minus 10. So again, I'm not changing my first value, and I'm not changing my last value. I'm just putting things into the middle. Okay. Sanity check. 15 minus 4 gives us what? 11. Perfect. Thank you. Awesome. Okay. Glad we're still here. Okay, so then what is our next step?
Factor by grouping.
Factor by grouping. Exactly. Same process as before. I'm just going to put my first two terms together, put my last two terms together. So what can I take out of 6x and 4x? Like, what is the biggest thing that I can take out of both of those?
2x.
Probably 2x. Yeah. Awesome. So then what are we left with when we take a 2x out of 6x squared?
3x.
3x. Perfect. And then a 2x from a -4x will give us -2. Perfect. Awesome. Okay. What about this second one? What is the biggest thing we can take out of both of these?
5.
Probably a 5. I agree. Okay. And then what are we left with when we take a 5 out? 3x. Perfect. -2. Awesome. Okay. Do our middle terms match? These two in our parentheses. Yes, they do. So we're good to go. We can kind of take these out. We have our 3x minus 2. And then what goes in our other factor?
2x plus 5.
Perfect. These two. Okay. Awesome. Do you guys have any questions about these? You guys seem to know what you were doing. So awesome. Sandy check.
Okay, we're gonna go over just a couple other examples when we have more terms of using that factoring by grouping. That was a great, so lead right in to what we're gonna do next. So typically, I think the only thing that we haven't really covered is just typically that there will be, well, I guess we've actually talked about all these bullet points already. So feel free to read over them. Good review, but you guys, I think it's even better that we reviewed it in practice. I'm just gonna go ahead and get into the problem then. Okay, so yeah, here we have 4 terms instead of our trinomial 3 terms, but it's not much different from what we were doing before. Okay, so what do we think our first step is?
Group them.
Yep, group them. Yep. Since we already have 4 terms that we can put each into a group of 2, we're great to go ahead and start grouping them. Okay, I like to write mine with parentheses, so we're gonna write it like this, plus 30y. Okay, and I choose to keep my negative inside my group and add a plus instead, just to help me keep track of things. But again, it's really the same thing that we were doing earlier. Okay, so what's our next step?
Take a factor out of each one.
Yep, we want to look at what we can factor. So this first group here, 6xy plus 30y, what can we factor out of each of those terms? 6, awesome, 6. Anything else?
A y.
And a y, yes. Yep, 6y. Okay, so what is that gonna make our first term be in that group?
X plus 5.
X plus 5. Beautiful work.
That.
Beautiful work. Okay, what about our second group?
4.
4? Perfect. Anything else with the 4? Okay. So I'm going to keep that plus there, and then we'll pull out a 4. Okay, what are we going to be left with on that after we take out a 4?
We need a negative too.
Negative X. Oh wait.
Mm-hmm. We can keep going with just the 4, and then we can keep
Yeah.
factoring
negative
after
X
that.
and then negative 5.
Mm-hmm. Perfect. Okay, so this looks really similar to one of the problems we saw earlier. These terms inside the parentheses are almost the same, but we have that negative x and a negative 5 instead of a positive x and a positive 5. So that's just a little hint that we're definitely on the right track. There's just a little bit more that we could factor out, and we can take out the negative. Okay, so I'm going to keep our first term, 6y x plus 5. And then since we're going to take these negatives out of there, we're going to turn this into a minus 4 times x plus 5. Does that feel good? You feel good about that? Okay, awesome. What's next after this? You guys are masters of this. Doing so good.
So just X plus 5 and then
Mhm.
in the other parentheses 6y minus 4.
Beautiful.
Perfect.
Beautiful.
It's clocking.
It's going. You're cooking. You were cooking. Okay, insanity check. Beautiful. Way to go, guys. Okay. Oh, and that was our only example with that
Oh,
one.
well,
So,
there you go.
which
Okay.
is, you guys are doing great with it.
Yeah, any questions about these guys?
I think for this one, it gets more confusing when you have to reorganize them.
Mhm.
That can also be a part where I get confused. But
Like this from here to there. That's
no,
it, or
Like
not
at the
this
very,
specific.
very beginning?
Yeah, like when you have to reorganize what variables are gonna factor out to keep factoring it, you know?
Okay. So just let me ask, is there a specific part here where you were just like out of the blue? Like where did that come from?
Oh, I was just related to this type of problem.
Okay. Do you want me to?
Yeah.
Oh, yeah, go for it.
So you're saying like they give you a whole bunch of terms and you have to make it into this before you even factor. Okay.
Okay.
Okay. So the rule of thumb for these, at least something that helps me, let me know if there's anything different that helps you. If I see 2 variables, so like the 6xy, and I have 2 of them, I'm going to take the one that has the most and I'm going to put it first. So just like when we had our x squared or our x cubed, and then we factored from there, these ones have an x and a y that I don't know what they are, and they're being multiplied together. So I'm going to bring that to the very front.
Okay.
From there, you're noticing that 30 is multiplied by a y and then the negative 4 is multiplied by an x. Those ones are kind of similar to like a negative 4 that you would have with like an x attached if you had an x squared minus 4x. It doesn't necessarily matter which way you put them, as long as you have them second, they're good to go. And then I put the one that has like no extra variables at the very end, so nothing with an x and nothing with a y. So yeah, I don't know. Does that help at all?
Yeah, it is.
A little bit. I don't know. Is there anything different that you do when you're trying to just like? Because sometimes they'll just give them something like negative 20 plus 30y minus 4x plus like 6xy, something like that, right? And then you want to like reorder it.
Yeah, I mean, I definitely agree with what she's saying. Like, whatever term has the most variables, whether that's like the highest power of x or it has an x and a y, whatever that looks like, that term should go first. And then whichever term has the least amount of variables or no variables would go last. Usually the terms in between we kind of mix up. Like this one I just tried, okay, let me swap the middle text and see if it still works. So here's my group here. I guess maybe I should do it on the board since it won't be captured in the recording if I do it.
I can erase this as well. Then you have a little bit more room.
Okay, what I was saying off camera is, that term with the most variables will go first, and the term with the least variables will go last. And then typically we can kind of mix up the terms in between. If you have like all x's and it's like x cubed something plus something x squared plus something, we usually just write them in descending order. Our x cubed, then our x squared, then our x, then our constant. But like a situation like this, we should be able to mix them up and still get something factored. Okay, so like here, if I were to switch those two inner terms and make these my groupings instead, I would look at that first grouping. What could we pull out of there? Yep, an x.
A 2.
And a 2, yeah. So we can pull out a 2x. That's going to leave us with 3y minus 2. Does that feel good? Okay, what about that second grouping? What could we pull out of there?
A 10.
Mm-hmm. Yeah. So I'm going to do plus 10. And it's going to leave us with what?
3y minus 2.
3y minus 2. Okay, so then it's going to plus 10, 3y minus 2. So it gives us a different factoring, but we can still factor it. I would hope that your CBEs would be able to accept either.
I think they would be able to accept both.
Yeah, should be able to like accept both correct answers because they're both definitely correct.
The only reason the second one is different is because if you notice the 6y minus 4, you can pull a 2 out and you're left with a 3y minus 2. And then what they're doing is they're taking that 2 that they pulled out from the 6y minus 4 and they're multiplying it into the x plus 5 factor. So that's why it looks a little bit different.
Oh wait, I did that backwards. I was trying to show what you were saying.
Oh yeah, sorry.
Yeah, no, you're good. I just did it backwards then. It's 2.
Yeah, and then you have
X
an x
plus
plus 5.
5.
Yeah.
3y minus 2.
So I guess if they said to fully factor, this is actually probably what you would want. Is like a 2 times an x plus 5 times a 3x minus 2. Because there's nothing that you can factor out of either of the terms. It's just going to have the 2 on the outside. And that's why the 2 that we have above is a little bit different, is because the solution that we have isn't quite fully factored. Yes. So,
Yeah. I mean, I guess one last tip about that is if you're like looking at your terms and you're going to group something and you're about to put like two terms next to each other and their coefficients, there's nothing you can factor out between them. Like it's a sign to probably try a different term next. But I would think most of your problems, you should be okay switching terms around. But if you're like, get to the point you've ordered things and you look at your first grouping and you're like, there's nothing that can come out of this. Maybe go back and try switching them. But don't be too scared that you have to, like, there's a perfect order to put things in. Just either I would put descending order with your powers of x, or, you know, the most variables first, and then the least variables last. Does that feel better?
Mhm.
Okay, awesome.
Thank you.
Yeah, for sure. Hey,
Perfect. Okay, any other questions? These are really good. Good. We're vibing. Okay, awesome. So we get our special factoring formulas. So in class, she talked about differences of squares, where the first term is a perfect square, the second term is a perfect square, and you have a minus in between. And when you factor that out, you're going to have an x plus y in this case, and an x minus y. So the only thing that is different in these two is going to be these middle terms, this plus and this negative. When you're having like a perfect square trinomial, where you still have your perfect terms at the very ends, but you'll have either a plus 2xy for a positive, or you'll have a negative 2xy for a negative. So we'll kind of go into this a little bit more, but those are kind of the special factoring formulas. So, okay. Wow, this is glorious. Okay, first, is there anything we can take out that might make it a little simpler so that we don't cry?
3.
Perfect.
Or
I like a 3. We can also do a 6. Okay, perfect. Is a 6 the biggest? I think a 6 might be the biggest.
yes.
6 is the biggest coefficient, yes. Perfect. Okay, is there anything else that can come out? So I'm gonna write down a 6 here.
X cubed.
Perfect. X cubed. Awesome. So I'm just gonna take that out of here. Okay, perfect. So what do we have left? 12x to the 5th divided by 6x cubed gives us
2x squared minus 3x
Whew.
plus 1.
She's fast. Perfect. Awesome. Okay. Sweet. So in this case, I think it's just we're not gonna be doing any of our fancy rules yet. But we don't necessarily have to worry about our 6x cubed anymore. We've already factored that out. What are I guess what is left that we would need to see if we can factor it after the 6x cubed? What is left from our original equation?
What?
Would you just focus on trying to factor the trinomial?
Yes, just this guy. Sorry. Probably a very bad question. Okay, so we're taking the 6x cubed out. We just have to worry about focusing on the inner stuff now. 6x cubed, there's nothing else we can really do with that guy. He's just sitting out there. He's waiting for the rest of them to figure out their lives. Okay, perfect. So, do we have a 1 in front of our x squared?
No.
We don't. What do we have?
2.
We have a 2. So what are we going to have to do to be able to figure out what we can factor for our greatest common?
Multiply it by, wait, it's already.
So yeah, so we have a 1 at the end here. We don't have a 1 right here. So what were you saying?
Just do 2 times 1.
Perfect. 2 times 1 is going to give you 2. Sometimes I feel like it's opposite, where you have like a bigger number on the end and then like a smaller number, but it's going to be the exact same process. Okay, so what are our factors of 2?
1 and 2.
Perfect. Okay. And we have a positive 2 here. So we either can have what?
A negative.
A negative and a negative, or positive and a positive, right? Okay, so let's look at our middle term. We have a negative 3 here. So, what do you think we'll want to use?
A negative.
The negatives. Perfect. So, I'm going to just write negative 1 and negative 2 out here. Same thing, negative 1 times negative 2 will give you positive 2, but it will add to give you negative 3. Okay, so I'm just going to keep the 6x cubed outside of our parenthesis. We are going to keep the first term the same, and then we have, do you guys want to do negative 1 or negative 2 first?
Negative 1.
Negative 1? Perfect. we have negative 1x, and then we have negative 2x, and then we have plus 1.
Can
Perfect.
you not write them in the two parentheses?
We can do them in our two parentheses. So you're saying like have a parenthesis here and then a parenthesis here?
Yeah.
Yes. So either way you want to do it is perfectly fine as long as you know which ones you're grouping together.
Yeah.
So, okay, with our first couple terms, what can we take out of 2x squared minus 1x?
2x.
This guy. We can't quite take a 2 out of both of them because I don't think I can take a 2
Oh,
out of 1.
Just x.
Just x, yeah. Perfect. So then what am I left with?
X minus 1.
Is there anything else
Oh,
before the x? No,
sorry,
you're good.
2x minus
Perfect.
1.
Awesome. Perfect. Okay, perfect. Yes, 2x minus 1. Alrighty, what about this second one? We want it to look the exact same as this 2x minus 1. Is there anything we can take out of this one?
The negative.
A negative 1. Perfect. So then what are we left with?
2x minus 1.
Awesome. Okay, so our terms in our parentheses match, which is fabulous. So what are going to be our two factors for the inside part?
2x minus 1 and then x minus 1.
Awesome. Okay, perfect. And we still have this guy out here, right? He was waiting for them to figure out what they were doing. So he's just gonna tack along on the back. Or you can put him on the front, whatever you want to do. Okay, let's do a sanity check. They tacked him on the front. I feel like usually you want to tack him on the front, but I definitely did not write it that way. So, okay, any questions about any of this?
I have a question.
Yeah.
Is there any time that you have to do it in like more of a grouping style instead of I really like to do the trial and error way. You guys know what that is? It was on one of the videos that she put on the homework. And it's, I don't know, it's like the same but different.
As in like factoring goes or like.
So instead of like writing,
guys.
Thank you, I tried.
Yeah.
this probably isn't like a super important question, but instead of like writing all the terms on the bottom and then grouping them and then doing grouping, you just draw parentheses, like a set of parentheses, and you put stuff where you think it should go, and then you try things until it works.
Yeah, you can definitely do it that way too. So what you're saying is instead of doing all of these factors and then writing these two and then grouping them and doing all of the stuff like that, you're just like, okay, well, to get 2x squared, obviously one of my terms is going to have a 2x, right?
And a 1x, yeah.
And then a 1x, perfect. And then, okay, yeah. And then, I don't actually know what your next step would be. What would your next step be? What would you do in this case?
So then I look at the 2 that we got when we multiplied the 2 and the 1 first.
Okay, so this guy.
And so we put some factors in there of 2, so you can just throw in like a +1
Okay,
and a -2.
perfect.
And then,
And then you just kind of multiply it to see what you get.
yeah, just check it.
Okay. Yeah, you could definitely do it that way. I mean, either way, you're going to hopefully get the correct answer. Is
I
there
guess I have
anything-
a thought with that. Is like those two numbers that we're putting in, those constants in each of the terms, instead of pulling those from the factors, would we be wanting to look at like what's going to multiply to be our last term? Because if we check here, like this, I guess in check we end up with x minus 2, but when we go to multiply out, maybe this is like a shortcutty way, like one more thing you could look at to shortcut how much you're guessing in
So instead of like saying this as like a 2, you could look at this very last term, like here.
And say, okay, we're either going to have, since it's 1, it's got to be 1 and 1. It's either going to have to be +1 and +1 or -1 and -1. So maybe like look at that to like shortcut your guess and check.
Okay.
But I don't think there's a situation where that wouldn't work.
Yeah, not that I can think of. So yeah, I guess what we're doing to be able to find our middle terms as far as this factoring and then grouping for the middle goes is it just gives us like a foolproof thing that we can then see. But this way works as well, where you're looking at the first term and you're saying, okay, well, one of my terms has to have an x, one of them has to have a 2x. And then you're looking at your last term and you're like, okay, I'm going to get 1. So I can either put +1 and +1 or -1 and -1 because that's going to give you a positive 1.
So
So,
it ended up being -1 and -1.
Yeah, so then,
Yeah,
That's
I don't
what
think
you're
there's a
saying.
situation where it doesn't work. I just think if you get into a situation, because 2 and 1 each only have factors of 1 and 2 and 1 and 1.
Mhm.
But if you get a number like even 12, which is gonna have like 1 and 12, 2 and 6, 3 and 4, that's like a lot of different combinations you might have to go through.
Yeah.
And so this method, you just don't have to worry about picking the right numbers first.
Right.
But it's just gonna
Mhm.
show you it, but it wouldn't not work. I can't think of a situation where it wouldn't work. Yeah.
That answers my question.
Yeah, I really like that though.
Yeah.
So like, yeah, for this one, 2 and 1 are pretty simple. But if you ever got into like 12 or, I don't know if there would be another number they would give you that's super crazy, but
Yeah, I don't know. I would just think if you have a number in the teens, like 12, 15, or
yeah.
I guess even 15 wouldn't be bad. But you know, there are just some ways that it could be a little bit more complicated and give you more combinations.
For sure.
So
Thank you.
yeah, you're welcome. Okay, awesome. So that ends the CBE for today. If you guys have any questions though, you want to review this video, they will be putting it on our YouTube channel. And if you guys have any questions that you want some help with, the tutors and recitations will be in the Math Tutoring Center. So yeah.
Yeah, and as you guys go and take the CBE, we should be able to pull up past attempts and be able to like go through them with you if there's a certain problem you get really stuck up on. And yeah, since I'm a tutor, I'll put a special plug. You don't need an appointment. We're open until 8, Tuesday, Wednesday, Thursday, and then our closing hours are a little different the other days, but we try to be really available for you guys. We have a lot of good tutors and a lot of great recitation leaders too, so please come in if you need.
What times are you guys in the tutoring?
Like us specifically?
I'm there Tuesday and Thursday mornings from 8:30 to 9:30, and then my hours are kind of sporadic. So Tuesdays 8:30 to 9:30 and 12 to 1. Wednesdays from 2 to 4:30, and Thursdays from 8:30 to 9:30.
Okay.
And then I'm in the MLAC on Mondays and Wednesdays from 2:30 to 4 in the afternoon.
Oh, and this Saturday I will be there from 10 to 2. So
Awesome.
if you want help, please.
Okay.
Yes.
Thank you
So-
guys.
Yes.
Yeah, you're welcome.
Of course.